This is the Empower Podcast, released August 4th, 2019. Episode 453, Vertically Integrated Design Engineering.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hey, welcome back, friend.
Thank you very much.
It's been a while for us, yeah.
It has, yeah.
I was thinking about it. I was putting some numbers to it. I was like, I think I've sent 3 boards to be fabricated since Dave has been last on the show. So we have lots to talk about, I'm sure. But
Yeah. Brag.
Not brag. Just work.
Are these your personal boards, or are these contract jobbies?
These are all contract things. So I can only say limited things about them. Other than I've been doing some RF stuff, and that's been interesting learning. But the thing I wanted to mention to you today, I don't know if you saw my tweet this morning. I was like searching around. I have this new project that I'm looking to do for an event that I have coming up, and I just want to make something like blinky and distributed, and I want to be able to like control stuff around the room and stuff like that. And so I was like looking on DigiKey looking for like cheapo chips, pretty much just like searching by increasing level of cost. I found one on there that's 57 cents per chip in like less than 100 quantity for a Bluetooth with a Cortex M0 on it. And it's like, what?
I'm looking at it now. There's zero stock though.
Oh yeah, who do you think bought them all? I bought 245 chips. It's right before I tweeted that link. Yeah, I wasn't going to tweet it without actually buying out all the stock.
Right. And buy before tweeting.
That's
it's
right.
Like it's like that. Every time the fire alarm goes off, I like tweet before I leave. It's like everyone goes, no, tweet after you leave.
That's right. Yeah. Yeah. So I don't know. Like I think I'm not sure if I want to use it for that project because I think I might want to get more distance. But what I want to ask you about is just. I've got an idea where I want to like have a bunch of things distributed around a room and just blinky stuff really. And so I want to have it like distributed around a room. I want to kind of have to basically broadcast all these things. And I was wondering how you might do that sort of thing. Thought we could kind of do a joint design where I pick your brain.
Oh, God. Well, I'm not into the RFE.
Yeah, it doesn't have to be.
World?
So my first thought on this was actually doing IR, and so doing like a blasted IR type thing where so basically doing like
and it bounces off the walls, bounces off everywhere. Like
exactly.
If you're used to it, you don't have to point your TV remote control at the TV.
Exactly.
You point at the roof and it bounces around.
So this will be an outdoor event, and it'll be nighttime when I do it. I think I've seen Sammy.
Outdoor is a fail for infrared, I believe.
Oh really? Okay.
Yeah, because there's too much. Don't quote me on that, but there's too much. Yeah, infrared. You get swamped.
Oh yeah. You mean when it's light out? So it'll be dark out.
Yeah.
I agree.
Okay,
If you have the sun, I was talking to someone about that too. It's like if the sun's out, it's just going to bring the whole noise floor up effectively, and then you need a lot more discerning type of things.
Right.
So I was thinking about that, and then I was thinking like how do these garage door transmitter, maybe like dig into that some more too.
They're like 470 megahertz or 800 megahertz. One of the there's specific bands, and it varies by country.
Right. But I'm just thinking like what is like I'm trying to get like a BOM cost of less than $1. So I definitely want a micro on there of some type. Just do breathing LED type stuff, and for be able to shut down low power mode stuff like that. But just thinking like. What are some cheapo ways that I can maybe broadcast these things so they wake up, check if there's a message. If there is, then they do a thing. If not, they go back to sleep. That like standard kind of stuff.
But not only cheap, you want easy to implement.
That's true.
Right?
Yeah.
So let's say, you've bought these microchip ultra low power BLE system on a chip package for your 50, 40 cents or whatever it was. Yeah. Right?
Right. Then
you work forever to implement the protocols. Like, don't ask how long David too has been working on implementing the USB stuff for the micro supply, right? It's months. Right. Just to get it done properly and talking and doing everything else.
Right.
So
and there's so many like iterations and so many different use cases and corner cases and stuff like that.
You might want to look at the Ant protocol, perhaps, but then again, I don't know how easy that is to implement. There's like
I was looking at all these transceivers, and like getting a transceiver less than $1 is actually really tough, and so that's why I was thinking like an IR element is really cheap. Maybe just having like a simple LC receiver kind of thing.
That's how I would do it. I would keep it dumb. I wouldn't implement any high level stuff like Bluetooth. Like maybe like ANT or anything like that. Perhaps I'd just like dumbass broadcast. It's just broadcast, right? So these things don't have to transmit back.
Right.
Okay.
Right. I thought about some more things that I could do if I, broadcast is definitely one of the main things I wanted to do. And I was talking to a friend about it. He's like, Bluetooth's not great about like distance stuff too, right? Especially if you're outdoors, it's going to be humid climate. As the humidity goes up, then the RF, the 2.4 gigahertz,
and everyone else has
down.
their Bluetooth phone enabled,
Wi-Fi,
so it's swamping the, Yep.
Yeah, and so then he's like,
I would seriously blast it.
Yeah.
With a dumbass simple serial protocol, so you can do it in like 10 lines of code.
Yeah.
You don't have to set up stacks and all that sort of BS and have packets.
Well, the other crazy thing I was thinking about, though, is that at 54 cents, this might be just as cheap just to put this thing on there. And
just as a micro, right?
Yeah. Not really. I don't. Please don't write in, everybody. I get it. There are cheaper micros out there, but like, 54 cents for a micro is not bad in low quantities. So
it's pretty good.
Yeah, and something to be like, well, you could do a PIC 10, and you could, whatever, 10 8-bit or whatever.
Well, interestingly, I am going to do a video on this soon. But the 3-cent microcontroller that I did the video on, those Hadouk ones, right? The that you can buy from LCSC, and someone or several people have reverse engineered all of that. They've now written their own proper C compiler. Well, they've now used another added support in a C compiler for it.
Oh, cool.
And also they've done their own, they've reverse engineered the programming protocol, and now there's like an open source programmer board for it as well.
Wow, that's great.
For the 3-cent micro. So I want to try it out. Yep.
Oh, wow.
And it's not the GCC C compiler, it's another one. If you could rattle off names of some other open source C compilers, I could probably tell you that's it. This one like supports
LLVM?
like 8051 Z80s. I think it starts with S or something. Anyway, I can't remember, but it's been reverse engineered. So I want to build that up and try it. So that's fantastic, right? Open source solution exists for a 3-cent micro. This is perfect.
And for
something like this. You just need a dumbass serial protocol. So you only need like hundreds of bytes of memory, right? You don't need like, kilobytes of memory. You don't need 32K of flash on it to just receive a broadcast serial protocol and flash a few LEDs.
Right. Yeah, and I think it's about like how much time I have and to put into this thing anyways.
No, of course. Yeah, exactly.
But,
that's why I reckon you'll get stuck down in the software stuff.
Yep.
That's why I think you need to prioritize that as the solution rather than
right.
focus on, I'd rather pay $1 for the chip and have the software just done and working than pay 50 cents for a chip and have to.
Yeah, that was interesting. So Mike Harrison was over on Embedded FM a couple weeks ago, and Mike had pinged them basically saying, hey, I want to come defend PIC parts. And it turned into a good discussion, but it was interesting hearing, the embedded side of things. And, Alicia and Chris were talking about like they're not, they're not against it, but they weren't as big of fans of like the PIC stuff. But then Mike was talking more about the logistical side of where that comes from. And like from that, I think it actually was a good, it was really just like looking at it from two different sides too. It's not that there is a right answer. It was just that like Mike was looking at it very much from the hardware, focused on the manufacturing side of things. Whereas Alicia and Chris were looking much more at like the, really digging into a thing where, because they're usually working on projects that are, have a bigger support team around it and stuff like that too. Yeah, so it sounds like kind of a similar argument you're making here.
Oh, it's totally different. Mike is absolutely, I haven't listened to the episode, but I know exactly what he's talking about. Yeah. Mike is absolutely correct. He's built his ecosystem around the PIC parts. Right. That's why if anyone comes to him as a contractor and goes, I need this done, he's not going to dick around, this STM32 micro is a bit better. Right. No, screw it. Just use the PIC for everything.
Right.
Because he's been working on those for a decade. He's a certified PIC, person, the microchip pick program or something.
The
believe.
approved vendor thing. Right.
Approved vendor, and he knows it back to front.
Right.
And it's like, he can just roll that out in 10 minutes while you're still dicking around downloading the C compiler for this microcontroller you've chosen.
Right. And that's a good point. And so I was thinking about that too. It was, so like I was just finding this because I was just literally searching for the cheapest thing. And like you're saying, I'm going to have a ton of startup time and whatever else. Usually the right micro is one that you can get up and get running fast. And like Mike, so we've talked to him around here a lot before too. It's he has libraries ready to go. He has stuff ready to go. Sure. Like everything else is just and I am treating this as more of an academic exercise, learning a new process, learning a new thing like that. So,
right.
And I might not even use these Bluetooth chips for this specific product, but I mean, at 50 cents a chip too, you gotta do it,
we had that problem for the micro supply as well. It was like, which micro do we use? Okay, well, it's easy to pick. No pun intended. It's easy to pick one that you've used before and you're familiar with, right? Mm-hmm. And it's like, but no, because we're manufacturing a solution. It's got to have, it had to have the right number of LCD drivers. It had to have, all sorts of, the right. All sorts of, stuff that had to be right. And we went through various brands. It wasn't just, we're going to pick the one that we're familiar with. Ultimately, we did end up with an STM32, but...
which you have used before, you're saying?
Like is that
what you mean?
Sorry?
Does that mean, because you're saying ultimately we did because you used it before, like it just shook out like that? Or what do you mean by that?
No. It actually popped out of the selection matrix as the best part.
Oh, okay. Yeah.
So we were brand... agnostic on that, and it was like if microchip popped out, if some other one, if a TI part popped out or something like that, then fine.
Yeah.
It. We'll use that.
But on the next project, that's the real key, right? Is like if you guys, once Maker Supply's out and it's working right, you spin the next one.
We would use it again.
Yeah.
We would. That'd go to the top of our list. Then the selection criteria would be not what is the best part. It's like, can we use this part again?
Yep.
Right, that's our first step approach, and if we can use that part again, then it's almost a certain thumbs up because you've already used it, you've got experience with it, it's in your bill of materials, you've got the parts, and you're probably going to use the same assembler again, so they've got them loaded on the machine. It's like there's a whole bunch of advantages to going with the one you've used
I'd say
before,
just the
and that's
switching
why
cost and the
Mike
pain.
sticks with pick.
Yeah.
Oh yeah, no, it's huge.
Yeah,
it's huge. But sometimes, as a contractor, you have to, because they might mandate, oh no, we're a TI company. We always use TI. You must use TI. Yes, sir. Thank you, sir. I'll charge you for, I'll charge you $100 an hour to, learn how to
figure it
TI.
out. Right, exactly.
Yeah, right.
I think the best, I think that, in a best case fit with like contracting and stuff like that, you're finding someone who already is in the space, they already know that part, they're already ready to go, because then that's going to just be few hours.
If you're looking for a contractor, you generally don't care, right? It's like you're looking for a contractor because you don't know the difference between a TI and an STM part. You just want someone to do a job. You've got some high level specs.
Yeah, that's a good point, actually.
Do this.
I was really worried when I started doing consulting stuff that someone's going to come to me and be like, yes, here's this great job. You have to do it with Altium Designer, and I'd be like, I don't really do that.
Right.
But yeah, you're actually right on that case. I have yet to find someone yet who they're like, yeah, well, we prefer you to do this, but if I'm like, I'm not going to charge you for the switchover if I have to do it, that kind of thing. I think that has been. That's been fine a lot of the time. So you're right.
Well, it's like Mike again. He's a great case example.
Yep.
He's a great niche case example. I believe he uses like a Circuit Maker 2000, which has nothing to do with the new Circuit Maker. I think he uses like this is a real old school program that hasn't been updated for like 15 years or something. He still uses that because it just works and it does what he wants.
Yep.
I believe.
Yeah, I think he did.
I'm wrong,
I think I remember him talking about that.
Yeah, and it's tied into his pick and place machine. He's written scripts to automatically get the bomb out of there and program the pick and place, and it's like it's all fully optimized and you don't change that.
Yeah. I think especially
once you've got systems in place.
Yeah, once you're doing like vertical integration type stuff like that too, it makes a lot of sense. And then, I mean, that's like, so you think about taking stuff to manufacturing too, like you're really optimizing a process, and anything that really moves outside of that process, that's a huge change. And that's like an entire project for someone that's in the manufacturing engineering space, right? They're like, okay, well now we're going to move in this new slot to just replicate that behavior, and it's kind of the same thing with vertical. I guess it's not vertical manufacturing in that case. It's vertical like design engineering almost, of like if you move outside of this process that you're really normal and used to, then there's going to be problems and issues and stuff like that, and really just time. It's just going to take a lot more time. Sure. Yeah.
So yes, my advice: stick to the easiest software solution.
Yeah. Okay.
And you'll be sweet.
Yeah. Well, the other thing I was interested in doing this for, another thing I've been playing around with. So I've been doing more RF stuff, like I said, and that's been interesting. And I was like, well, I could give a talk on this.
Right.
Which is a terrible idea. Why do I do this?
Right.
Giving a talk at Chaos Camp in 3 weeks in Germany.
On a subject that you're not a specialist in.
Luckily, I'm giving it in the talk in English. That'll be helpful. I don't have to learn German, so that helps.
Oh, okay, right.
But yeah, basically, it's like this is a talk about the perspective of coming at RF from someone who started in the DC world, and DC is actually DC, and not like what a spectrum analyzer says is DC, and like we started like a megahertz, so we're cool. That's DC, just kind of my learnings there, and hopefully that'll be a good talk. We'll see how that goes. But hopefully, I'm hoping to kind of give that talk more than once. I've actually submitted it more than one place, and maybe I'll actually give a talk a second time at some point. But if people are going to be at camp as well, I'd love to hang out too. So if you're at Chaos Camp, which is in Germany in a couple weeks, in Berlin, please give me a shout, and we can meet up. So that'd be a lot of fun.
Cool.
Yeah.
That'd be awesome. Is that every year or every 2 years?
It's every 4 years, actually.
4 years?
Yeah,
oh, wow.
yeah.
Okay.
So it goes, last year was that other camp I went to, which was here in the States, up in Seattle. That was tour camp. There's also one called EMF, and that's every other year. And then there's a second camp that's in, I think, the Netherlands, that's every 4th year. So like if you want to, you can go to a hacker camp every year. It'll just be a different camp.
Got it.
So...
Yep.
This is the one put on by the same people that do Chaos Communication Congress, which is every year.
Which is there? I thought it was. Yeah, that's the
that's like
Congress
a real conference. That's like a indoor conference right after Christmas in Leipzig or somewhere else. And
that's the conference that everyone wants to publish this stuff at.
Yeah, that's a big one.
Yep.
Yeah.
I think there's a fairly high standard for what you actually present there, isn't there?
More than camp, because they put that in my crazy ass talk here, Dave. So
right, okay, right. But you're Chris Gamble from the Amp Hour.
Yeah, that doesn't matter if the content's not.
No.
We'll
okay.
Yeah.
Name doesn't do it.
Yeah,
huh?
that's right. It's egalitarian.
Right.
But yeah, I'm really looking forward to that. But so I've been playing around with RF, and that's the other thing I was thinking about is like doing some antenna design. I've been looking into getting a VNA, and so that's been in some interesting stuff. Yep. Looking at some of the low cost options. Shahryar, who's been on the show before, he has a couple good. I mean, he has a bunch of videos about really high end stuff, but so low end stuff too. There's one called I can't remember it now. Feng? No, good something.
I do know the name of it. Yep.
Yeah.
Yep. There's a couple of low end. Low end, are you talking the couple of $1,000 one or the couple of $100 one?
Yeah, this is the $2,000 one.
Right.
Yeah, there is one that's like the mini VNA is like.
We talked about this like a couple of months back.
Oh, did we? Oh.
I'm sure we did.
Oh, okay.
Yeah, I'm sure we did.
Okay. All right. Yeah. So looking into that kind of thing and just building up equipment, stores, and learning stuff. And I probably didn't when I was talking about the book that I was reading, the microwave engineering book. And so reading more stuff. And actually, there was an interesting thing. I downloaded a book there's a Kindle book about RF layout, and I was going to ask you about it and if you've ever done anything like that.
I have done limited RF layout, yes.
Okay.
But not real high-end stuff.
Got it. So like what did that like look like when you were, so basically someone came to you and said, hey, just do it like this, do it like that. Here's kind of the guidelines, or what did that look like for you?
It wasn't hugely difficult because it wasn't like microwave stuff.
Okay.
It was like the 600 meg range.
Mm-hmm. Okay.
So it wasn't really a big deal. I've done like a discrete transistor RF amp and stuff like that.
Oh, really?
You don't really have to take any. You just make sure all your loops are tight and everything, and you don't really have to care too much about major details like you do, like laying out like a DDR memory and stuff like that, all those controlled impedance traces with the ridiculously fast edges and timing requirements and everything. That's much more challenging than doing just your generic RF.
And you
stuff.
mean that's because like if you get like a 500 megahertz clock signal with fast edges, you could be up in the many gigahertz.
You're up in the gigs. You're up in the microwave range.
Yeah. Okay. Okay.
Bingo. And just timing and skew requirements and stuff like that. Whereas RF transmission, you're not skewing against anything else, right? There's nothing. There's no timing requirements in there.
Oh, that's an interesting view on it. Okay.
Yeah.
Could you explain that a little bit more? I mean, so you just mean that like because all of this, like, so if you have like a 16-bit bus, they all have to get there at the same time. Is that what you kind of mean?
They all have to get there at the same time. That's why you have to use the serpentine traces, which is those wiggly, snaky traces that go around. So not only do your data pairs have to be the same length. So, if it's an 8-bit database, D0 to D8 all have to be the same length. And because when you round it on the board, they're not. They all have to go around different bend radiuses and things like that, right? One of them is going to be, the one on one side where it curves towards is going to be shorter than the one on the outside. It's like going around
like being in a track race, right?
It's being a racetrack, right? You have to stagger those, start
I would know this
points
because I'm a very fast person and I used to run indoor track.
Right. There you go.
I was always on the outside.
Right. Yeah. Thinking that. Right.
I did not get the good starting positions, if you know what I mean.
Exactly. And no, PCB layout's exactly the same. When you because the chip is flat, of course.
PCB layout is exactly the same. Chris is not good at it.
So they're all starting at the same spot, and then you've got a curved track, and if they end at the same spot because they've got to terminate another chip with a flat edge, bingo, they're all. So that's why you'll see the wiggly traces. But then, not only that, do you have to get the each one the skew, what it's called, actually between each one is the same. The same lengths. You've got to match those lengths, but then you've got they're often a differential pair, right? If you're doing differential pairs, right? So you're doing an LVDS, differential pair or something.
Yep.
Then then those ones have to be matched as well, right?
Yeah.
So you've got, like they're snaking all around the place. You can have one that's slightly longer than the other. So not only is there a differential length problem, but there's a cross pair length problem as well. And and that becomes a lot harder. And they're all transmission lines and stuff like that. Whereas if you're doing an RF transmitter, everything's really just a tight loop. Right, you've got your you've got your discrete transistors transmitting, or these days it's almost
module.
It's
usually.
Almost always just a module.
Yep.
That's why if you go look at the PCB layout for a Wi-Fi module or something, it's nothing. It's a chip with a couple of passive parts around it, stitched down to ground. It's got a big ass ground plane on the bottom of it, and then a single trace which will be controlled impedance. He only got like one trace going out to the little patch antenna on the board, right? It's a trivial layout. Anyone can do a Wi-Fi board layout.
Yeah. My thing was always keep that the distance to the UFL connector, which is that little like plug-in.
Oh yeah.
People don't know what that is. It's like that little one where you see a lot of like antennas plug into that.
That little.
It's like a little nub
tiny
SMT
press-on
thing.
coax.
Yeah, exactly. Yeah.
Thing, yeah.
My thing was always just like, if I can get that as short as possible, I'm usually safe.
Yeah. Right.
Yeah.
Yep. And so it's not, it's not difficult at all, unless you're at the bleeding edge of something like, Sharia would be with his,
right. I was actually, I was looking at your Twitter page earlier today too to see what we'd be talking about, and you have the picture of the
That's a mistake.
The spectrum, yeah, of course. But the spectrum analyzer, the picture that you have as your background image is another one where you have the different filters that are built into the PCB and stuff like that.
Yeah, exactly.
So that's some much more advanced stuff that I would not be doing.
Open up a spectrum analyzer and take a look at that, and there's some art in that.
Yeah, and you've done tons of teardowns.
Then you've got to use your controlled impedance, Rogers material and whatnot.
Right.
And can't just get it manufactured at your local, 2-cent prototype.
Yeah, that's right.
2 cent. $2 prototype. Dirty, can't get it made at dirty PCB.
That's right. Yeah, it's not. I mean, that's when the PCB is a significant portion of the actual design as well. That's the
right.
It's not just routing from here to there. It's no. This PCB is the component.
Yes, PCB is the component.
Yeah.
That's it.
Yeah.
So, yeah. Anyway, but it's not a big deal these days unless you're doing something like, actually designing a high-end spectrum analyzer or something.
Yeah.
It's usually just a single chip solution. You put a ground plane under it and whack.
Yeah.
You stitch everything down the ground and, know.
I just actually posted
Bob's your
today,
uncle.
too, the TI has an older app note 058, which we'll link in here. They also have like a range of just antenna shapes and sizes and stuff like that. And it's got some background info, too. So that's kind of a nice resource. So, it's nice to have. Found it helpful. I'm basically collecting info now.
Right, yes. Got it.
What can I pass off as my own with very, very small attribution links in the bottom of my presentation?
How do you store it all? Do you physically download the PDF and put it in the project subdirectory under documents, or what do you do? That was the go back in the day when I was a boy.
Yeah, I've been doing that for projects lately because I do a lot of GitHub stuff. But, for stuff like this, where this is more of a resource kind of thing, so like an app note like this, I would put this in my Evernote. I do Evernote for storage. And then the nice thing about that is it's actually stored on my phone. So if I'm like bored on the train, I can actually look at the PDF and stuff like that.
Yep.
What do you do? You actually do this local storage?
I am often project based, so
okay.
I'll be doing like local storage of in a documents folder.
Mm-hmm.
Like when I start a project, the first thing I do is actually create a subdirectory, project name, and then it'll have CAD. Like, it'll have ECAD, then it'll have MCAD for the mechanical stuff. It'll have documents, it'll have test, it'll have, pro code.
Yep.
So whatnot.
Yeah.
So
I like that too. And I think that's nice too. Like some people don't like that because then when you start getting into the code side of things, like the unbroken chain of commits.
Where's that? You have to remember where that old code was. Yeah.
Well, I meant
it's
too,
I
tracking
want
in revision.
I want to reuse that code. Right, it's like, I know I've written that routine for that I2C controller before I rolled my own. Where is it? I've got to remember which project I did that on.
I see. Yeah.
So it's like,
I mean versus
so
like
sure
a library like high level thing where you're
Yeah. Whereas but being the one man band that I am, that's how it works. Whereas if you're a dedicated firmware person, right, you're going to do it totally differently.
Yeah, right. You're going to write like high level libraries.
You would have different systems in place.
And you'd
have
them.
Yep. You would have go-to libraries that you reuse all the time.
Yep.
And stuff like that. So yeah. But no, I just don't do it. It's if I'm designing a project, I'm doing everything, right?
Yeah, right.
So it's like
you're David.
Yeah, exactly. So it's all under the one. It's all under the one subdirectory.
Mm-hmm. You guys doing that revision control thing yet?
No. Yeah, we do it on bloody Dropbox.
Yeah. Oh, that's right. That's right. You do
effectively.
That. Yeah. Hey, look, that's better than nothing. I've been saying that for a while. That's good.
Yep.
Cool, man. Well, how's the design progressing? It sounds like you guys are in the throes of firmware hell still.
Oh, it is the biggest firmware project we've ever done.
I believe schmozzle, is that the word?
It's a schmozzle, yeah. Now, if you want to do USB write, okay, look, I'll hang on, I'll pull up the chat log. I was chatting with David, who actually works from home now, basically. He's been working at home for the last few months. It's just easier for him,
I mean, Sydney traffic is not to be trifled with.
Yeah, no, there's no reason to be here, and he's just moved again. Like, there's no reason to come in. Anyway, here we go. Hang on, let me have a look. Here's the update for today. CDC and HID devices are being recognized by Windows. Their protocol isn't implemented. Only the initialization is, but that's a big step. Language and string descriptors we're working on. So we've got all these different modes. CDC, HID, there's another one. HID class, virtual COM ports.
Yep.
They have, we're talking about descriptors, composite class devices. You've got to get all this stuff right.
Yeah.
So, yes, but we're also using HID and storage HID for driverless use, mass
so
storage and firmware updates.
Drop stuff on there for updates.
Yep. And because we're going to be pushing our firmware over the serial port. Mm-hmm. And the problem is this is isolated, right? So what we've got is we've got, right? This is,
so you guys are doing isolated power off the USB, and then
we're doing isolated power off the USB, right? So we've got a USB processor on the primary side of the transformer, right? So this is where you plug the USB port into your computer or your phone or your whatnot, right? So that handles all the power delivery system.
Yep.
Right, which I can talk about in a minute. That's another can of worms we've spent months on, right? So that microcontroller has its own firmware, of course. It's got to handle all of that, all of the power delivery stuff. So it's got to negotiate all the power, and then then we have to have the ability to firmware update that, and then we go over an isolated optical serial link.
Right.
So a serial link to the main processor on the isolated side of it, and we want to be able to update the firmware on that over the optical serial link via the primary side processor, right? We want to update that secondary side processor's firmware via the primary.
Right. So you got to put it in a special mode and then actually dump.
You got to put it in a special mode, and it's got to do that, and it's got to do. We're doing VCP and CDC and HID modes and all these sorts of stuff. It's just nuts.
Yeah.
And I think we mentioned the other week that we had to. The other week, months ago, that we had to change processors on that.
Yeah, right.
Right, we had to change our USB chip on the primary side because it ran out of memory and couldn't do stuff that the manufacturer claimed. We started using it. We designed the board. We put it on there. Built prototypes. Started. It was kind of sort of working, and then we realized, it couldn't do what the manufacturer said it could do. All this sort of stuff, and their example code didn't work, and so we had to go, let's just abandon that. And we had to, respin. We had to redo the whole thing, start from scratch.
Yeah, that's nuts.
With a new processor.
Well, and then USB has its own, so there's got its own pitfalls and
if you want to do it right, if you just implemented a simple serial. USB serial virtual serial COM port or something. It's easy
with all the drivers.
Right?
Like the CP2102 or the
or something like that. Yeah, it's trivial, but no, we have to do a ton of stuff. So we have to, and then you've got to make it easy and driverless for the user to install. You don't want to be writing your own drivers and stuff like that on the PC.
That's right. Yeah, because then you have to distribute a software package and an actual update and stuff like that. Yeah. So there's a talk that happened at Teardown. Last month that was really, really good about USB and actually peering into what the data packets look like.
That's the thing. David, we finally found a use for my USB protocol analyzer, right? I've got the high-end USB protocol analyzer.
Yep.
And, I've never had really a project to use it on. And David says what he's doing would be impossible without this USB serial packet analyzer. And he found a bug in it that, he has to go back to the manufacturer and goes, look, I think this is a bug and I can't continue my work unless this bug is fixed.
Yeah.
It's how much you rely on those USB debugging tools. Because if it doesn't work, you just throw your hands up and go, I don't know.
Exactly. You just keep plugging it in, unplugging it, plugging it in, plugging it. Yeah. So Kate and Michaela gave this.
You cannot just use your scope and put it on the USB lines and expect to be able to see anything useful.
That's right.
It doesn't work.
Right. Yeah. So Kate and Michaela gave this really, really good talk about this. It's basically an open source USB tool, low cost. It's actually some of it's software based. So if other people are doing USB things, it was a really, really good talk. So I'll link that in too. But what do you do when USB goes wrong? I think one of the examples they gave was there was a reset packet that was maybe not even reset. It was one of the earliest packets that was happening and it wasn't working, and thinking about peering into that, other than seeing is there activity on the USB bus, other than that, what am I going to do? I'm going to be well, I guess I'll just try and solder this thing down again and see if it's just a bad solder joint. That's effectively the level. It's effectively operating without a scope.
Clutching a straw.
Yeah, exactly. I mean, it's cult cargo cult type stuff where I'm just trying this, trying that, holding the tongue out in the wrong angle. So I'm really glad there's tools that are coming out for that kind of thing because, I think it'll just make it more accessible.
And and for those who know the USB, I'm sure they're going to correct us, but David's saying, the HID returns just one endpoint, but CDC requires 3 endpoint. It's bananas.
Yeah, I don't know what
so
that means.
CDC is easily the most complicated, and expects he'll get notifications from the HID tomorrow, which I think is today. And and then he's saying, look, I can do this the dirty way or the proper way. And it's like, and I'm like, and he's going, which one? He's asking me, which one do you want me to do? Like, I can have something up and running quicker if I do it the dirty way, but we might get caught down the track where he'd have to rewrite the whole thing. And this would be after it's actually, we've shipped out units and it's actually delivered to customers and whatnot. And I'm going, no, Murphy will bite us in the ass. Just, spend the extra days. We've already spent, 6 months working on like various power delivery stuff and various USB stuff just on the software side of things.
Yep.
It was like I never expected it to be this, like, if I knew it was this much work from the get-go. Like, I thought that we'd just use a USB capable chip and the drivers would just work and like everything would be hunky-dory. It's like a week's work or something. It's like it should just like use the example code and it should just all work. But no, it's if you want to do it properly.
Right.
And I realized that you're aware of those portable soldering irons, those little USB powered.
Yeah, like the TS100 and
the TS100 and the TS80.
Yep.
I found out why the TS80, which I love. It's better than the TS100. Fanboys go wild.
Right.
It's right. It's really nice, but you can only power it from quick charge.
Yeah, that's right. Yeah.
Packs. Yep. Right, they use the quick charge standard. You can't power them from the much more popular and widespread power delivery (PD) standard ports. Right? Mm-hmm. Why? Because David's trying to implement PD, and it is enormously complicated. It's a shit show. If you want to do it properly, right? If you want to implement, that's why they just use the quick charge thing. It was quick and easy, right? Yeah. It was quick and dirty. It just worked. They just plugged in the chip and it probably just, used default code and it probably just worked.
Yep.
But power delivery's a much more complicated beast. So that's why that's why it doesn't support that. And it makes sense. Why support the lesser known and almost dwindling standard only when you're not supporting the most popular and biggest and most widespread one that's actually dominating because of the engineering work involved.
Wait, so which one's actually dominating?
The power delivery standard. That is the standard.
Oh, okay.
Whereas the quick charge is a specific Motorola. I think it came. It's a Motorola thing.
Got it. Okay.
Right.
Okay.
So so they developed it. A couple of other manufacturers kind of sort of picked it up.
Got it.
It was kind of, maybe it was like an open standard or something.
Yeah, I was going to say, is this all based on like reference designs and what's actually available? Like how like every Bluetooth speaker is the exact same reference design? Is it like that kind of thing?
That's probably what they did. That's probably what they did for the quick charge, and that's how they got their soldering iron, and that's what they. But but it only supports a small number of these packs, these battery packs.
Yeah.
Right, and that's what So just because they didn't want to do the engineering work, they've actually completely crippled their product into a tiny niche market.
Or Dave. You sell a thing that can only work on quick charge, and then you sell that for real cheap. You sell the quick charge battery pack for a lot of money.
You sell it,
it's sneaky like that. It's sneaky like that. Oh man,
we'll sell custom battery packs with the micro supply.
That's right. That's right.
Yep.
Anyway, the one is a loss leader. It's a loss leader.
Right. Yep. It's just, like the printers and the ink cartridges, right?
Mm-hmm. Exactly. Yep.
Right. Yep. Here's a free printer.
Yeah. Remember that was happening? Yeah.
Yeah.
I never
still is.
Yeah, I guess so. I don't. I remember.
I was at my post office the other day. I was waiting in line at the checkout, and I don't know if the post offices in the US are the same, but they basically, they're like a little shopping.
Mm-hmm. Yeah. They're trying to make margin on the other stuff.
Yeah,
right?
yeah. So as you're standing in the line, they've got all these things next to you, and you're just, I'll pick one of those. Often they got real good bargains there. Anyway, it was like, and they had like laser printers. It was like, they had like, they have like 2 of them. It's not like they have hundreds of them. You know, they have like 2 per store or something. And yeah, they'll have cameras. They'll have, you know, phones. You can, I need a phone. You know, I'll just buy it at the post.
That's different than here. Yeah, that's different than here.
Oh, okay. Yeah. Right. Okay. Anyway, so and there it is. Laser printer, $30.
$30
Australian.
Oh my God.
Right? That is like how much US? That's like $20 US.
Yeah, that's nuts.
Right?
I mean, that's like
retail at the post office.
Right. So that $20 is pretty much going to the post office. At least
pretty much
$10 to $15 of that is going to the post office.
It's just like, come on.
Yeah.
It's insane.
That's nuts.
Yeah. It was free. Like, it was like, in terms of a printer, it was practically free.
Yeah, that's great.
Yeah. Nuts. Anyway. Yeah.
Cool.
All right.
So, should we go on the list now? We have been on the list.
I'm giving a talk.
What? Where are you giving a talk?
Yeah. I'm giving a talk. At a school.
Yeah?
I was invited to give a talk on renewable energy.
Oh, I was going to talk about solar roadways, huh?
I asked this on the forum. I asked this on the forum, and like half the people said, yeah, they've got to know about it. They need to know about critical thinking. And the other half said, no, don't tell them anything negative. These kids need to be supported and live in their safe space. Well, they didn't say safe space, but they need to only be encouraged. Nothing.
I think inspired. Inspired is the
them.
word, Dave. Yes, inspired.
So, inspired. So, guess which option I'm taking.
Of course, you're going to take the first option. Yeah, we get it.
Yeah. But no, like 90% of my talk will be inspiring, and the rest will be, well, just sometimes, don't be so open-minded that your brain's full out.
Yeah, that's good.
Right?
Yep.
Yeah. And I do actually have a slide with the Carl Sagan quote.
That's great.
That Carl
Sagan
that's
a good one.
So,
when are you doing this?
I'm doing it Monday.
Nice.
So straight after this, I've got to finish off my slide because it's Friday here. So I've got to finish off my slide so that I can send it to the teacher there. The head teacher, so that they can not really approve it, but just like,
just check it over.
This is what I'm, is this sort of is this what you want?
Right.
Kind of thing.
That's great.
So,
that's great, man.
Yeah.
I'm not giving any talks this weekend, but I'm headed to Vegas tomorrow, and which is in August in the States. Great time to go to Vegas, of course. No. It's 110 degrees Fahrenheit. Or 42 degrees C.
Got it.
And whatever the number is. And
well, it's not. It's not peak though. If you went a month and a half ago, it would have been peak.
It's pretty bad.
No.
It's pretty bad.
End of July? No. Okay.
Yeah.
Yep. It's just coming off peak.
It's a dumb time to be there. But
anyway,
but there's a big security conference
Vegas,
there at Black Hat, and I'm helping past guest Joe Fitz with his workshop. He's giving a workshop for 4 days. 2 different workshops in each day. We're doing hardware hacking and reverse engineering for people who've never done hardware before. And it's very exciting to see how this is going to go. There's going to be milling machines, 3D printing, actual then just some of the standard having logic analyzers and SPY bus and actually like decoding stuff, but this is actually like making stuff, like making a PCB, making a 3D printed thing, making jigs, and doing it in a conference room at Black Hat. It's gonna be very interesting to see how it all goes, and I'm really excited. And actually, speaking of,
is this going to be recorded?
No. This is like one of those paid trainings. So this is
Oh, it's a paid thing.
Yeah. So like, and that's like a big thing. So like a lot, it's I'm still really not confused, but I'm interested in it. Like the security industry, man, there is just so much, like there's such a strong culture around training, and it's really impressive, but it's also like these are not cheap trainings. These are like the standard corporate trainings that are like thousands of dollars.
Right, yeah.
And
they're the thousands.
And they fill up, and then there's in Black Hat's like a conference that costs a couple $1,000s to go to. It's just like a standard industry style conference.
Oh, so you can't. So there's not just like a free. You can't just rock up to Black Hat.
No, so then like. I think B-Sides is lower cost, but then DEF CON is right after as well. So it's like a bunch of conferences kind of happening all at once in Vegas. They're all security focused, but then, I go to hang out with the hardware people.
Yep.
But I'm really excited because MG is going to be there. And if you remember MG, he's the one who was doing we talked about him on the show. He was doing the milling of the solder mask remember there was like a milled board, but it had solder mask on it.
Oh, yes, right.
So he's helping with the workshop as well, and I'm
Yep.
going to pick his brain about how the hell he was doing that. So really excited about that, and yeah. And then I'll be at DEF CON for a day as well. That's like the badge life stuff, and so again, if people are out and about, love to hang out. Yeah, it should be a good time. Inside, of course, not outside.
Cool.
So
Right.
yeah, yeah. So teaching hardware. We'll see how that goes.
We just don't have the same stuff here.
Yeah, like something
Don't
like that
have the
could.
same
I mean,
conferences.
you could do that at the like the Linux Conf is coming up in January, right? That's the one that.
It is. I think it's down in Tasmania. I think.
Oh, is it really?
Something-
Okay,
something.
cool.
I don't know.
Cool.
Yeah, I think it's down. But I don't think it's ever been. Can't remember the last time it was in Sydney.
Mm-hmm.
I've certainly haven't gone to it.
That's like one of the biggest ones,
yes,
though. I think.
Yeah, I'm not sure if there's a hardware aspect to it this time. I had a look a couple of weeks back at the website and I couldn't really
I thought
see
John Oxer helped do
anything.
like
So,
Linux conference stuff.
yeah, I know. That's what I thought as well.
Uh-huh.
But
All
anyway,
right, I'll take a look. I'm looking for somewhere to go in the cold depths of the winter, so maybe that would be a
right,
good time to come visit.
right.
Business travel, Dave. Business travel.
Of course.
Yeah. I think it would be one of the mini comps on there too. So we'll see how it goes. But there was a bunch of stuff. I thought down in Australia that you guys were doing some. I keep seeing RISC-V stuff pop up all over the place. I thought it was at Linux Conf. Maybe it was something else. Maybe that was actually just Tim Ansel at there doing that last year or something. But I keep seeing RISC-V pop up everywhere, including Alibaba.
Yeah, what the?
Yeah, that's interesting. So basically,
They have a chip group.
yeah. I'm not sure. We couldn't. We were looking at this article earlier. We couldn't really figure out why. I guess I guess Alibaba has server division, so there is that. They kind of operate like an AWS.
Oh, of course,
But-
yeah, like Amazon roll their own servers and
Yeah,
stuff,
yeah.
And Google and Microsoft all make their own servers.
Yep.
They also
Yeah,
like,
but
design
like
and build their own.
Microsoft isn't like Facebook has servers, Google has servers, everybody else. Most of them are not yet doing their own chips. I don't think. I think that's maybe
Right.
on the path, and maybe that's what RISC-V is going to kind of do more of. But it seems like in China right now, because of like all the ridiculousness with the tariffs and stuff.
The government, Huawei banning and all that sort of crap.
Well, and then ARM
Yeah.
stepping away too. It's like, okay, so now like what are their real choices in terms of chips? It's interesting if it's going to drive China to just be like, all right, we're just going to do our own thing. Who cares? Like they are very not as resource constrained, as they used to be.
So China's going to be like the Soviet Union of the 70s and 80s. They were just doing all their own chips. They were just copying. Like Soviets had their own industry, right?
Sure.
They weren't using Intel chips. They were like, right?
Right.
They were like rolling their own.
Less. I think it was less of a global.
They couldn't even buy like
global thing
TI,
anyways.
TTL chips, right? They couldn't even buy like just generic off the shelf TTL chips. So they have their own generic brand TTL chips.
Oh, okay. Yeah.
Right. If you open up any Russian bit of kit, it's like, yep, that's a 7474 flip flop, right? But it's not from any of the manufacturers you've ever heard of, right? It's all Russian.
Interesting.
They've got their own part numbers, they've got their own manufacturers, they roll their own silicon, and they copy it, often.
Yeah.
But yeah, it's like they had their own insular, complete industry.
Right.
Completely cut off from
Yeah, I
from the rest of the world.
I can't help but think that's
It's like-
not a. I mean, obviously, I don't think this is a good idea, anyways. But
No, it's a
it
bad
seems
idea.
like it's just a step backwards too, because then it's like people that would have been.
I know.
I like the idea of an open ecosystem, of course, with RISC-V stuff. I think that's great, right? And if this maybe pushes that forward a little bit, maybe that's an unintended consequence that's kind of nice. But like ultimately, I would think that there would just be more drive, like just more money in the system. Like, if Intel knows that they can make another $1 billion, they're going to keep pushing themselves internally in order to push out that next node or the next chip or whatever. Same thing with ARM and at TSMC and everybody else, right? It's just like money is the driver of economic growth. Usually the ones that are leading the pack anyways are going to continue to push forward to that next thing. If now everybody's going insular and it's like, oh, well, we're just going to do our own thing now and we'll take a step back, and it just seems like that's going to slow everything
fail.
down.
It's going to ultimately fail. It's just dumb.
Yeah.
But politics.
Yes. Realities of the situation. It's
getting in the way. Like, now all the rage is in the political circles is let's ban encryption or let's put backdoors into every encryption thing. It's like, no, it doesn't work like that, you dumbasses. It's like, come on. It's like, yes, the famous Australian Prime Minister came out and said the laws of mathematics are very commendable, but Australian law comes first.
Jesus.
Like, you dumbass. Our Prime Minister actually said that, uttered those immortal words.
Wow.
The laws of mathematics are commendable, but it's trumped by Australian law. So if we tell you to put a backdoor into an encryption system, you have to do it, even though it's not technically possible.
Jesus, yeah.
That's the level of dumbness we're dealing with when you reach the political level. Anyway,
I've been watching. So I watch a lot of these. So I get the Jetix Smart Brief. That's one that I get, and then I also get Woodstock Wire. Those are like two newsletters that I'll often use to seed the subreddit with stories and stuff like that. And it's interesting because I've seen a couple stories lately, and it's not trend making at all. It's just like my ears kind of perk up, or I guess my eyes in this case. And I've seen a couple like higher profile like manufacturers, like contract manufacturers, have started to shift operations and started to move stuff around. And when Scott Miller was on the show 2 weeks ago too, he was talking about that as well. Just that like industry isn't going to wait around for whatever. It's just they're going to go and try and find the best deal because they have to make their margins. And it's like I'm interested. I'd love to hear from people if like leave a comment if you're seeing similar things, just because it's hard to tell, right? No company's gonna be like, we're moving all of our operations. We had to shut down. Like not everybody's going to announce that unless they're a public company. So I'd love to just hear, boots on the ground kind of information from listeners. If it's like they're like, oh yeah, well, we're not traveling to China anymore. We're moving stuff to Vietnam or whatever's happening. I'd be interested to hear from people.
So you want a bunch of people to leak stuff to the Amp Hour?
That's right. That's right. We're the new source, Dave. We're
right.
I'm just personally curious. I mean, like, it doesn't seem like. From a high level, it doesn't seem like much has changed other than like, I pay tariffs now, and it's like, that sucks. But I'm at a very small level.
The whole tariff thing, like people just shrugged their shoulders and carried on, didn't they? That really didn't.
Well, at the level I'm at,
cause a big ruckus, did it?
But like, I'm not buying enough stuff from China for it to matter.
Well, of course, yeah.
So I think that that
so
could
I'm sure there's companies that have gone under because of the tariff.
Yeah, I think that it could really, really impact some people if you're on a thinner margin. So,
but I certainly haven't heard it. It's not like everyone's complaining on the forum about the tariff. It was like
right. I mean, like that's the thing. Like some people, I mean, it depends on what scale you're at, and if I think about like the engineers that I know that are like lower level, most of them are not going to be impacted, right? It's like, okay, like I'm shipping stuff into the States, it's less than $800, I don't have to pay tariff. That's fine, right? That's most of the people that I know doing stuff. If you're doing like low scale manufacturing in the States, like, okay, you're going to start dealing with stuff, but sometimes you're just like, well, what am I going to do? Switch over to a CM overseas? No, I'm not going to do that. But then if you're like at a medium or a large level, right, to where it actually would have really, really significant cost impacts, you're probably not allowed to talk about your work publicly, like and until the Amp Hour comment section, where we don't ask for an email or you don't have to use your real name, but please don't lie, But I'm just generally curious about it. So and that's the thing. I think it's one of those things where it's if it is happening in the background, it's gonna we're gonna find out from just contacts and hearing about it, and maybe a couple small stories here and there. I don't think it's gonna be like, because people don't want to make waves on the political side of things, they're going to be like, whatever, it's a thing. But I'm curious if it actually is having an impact, and I think there might be. So we'll see.
Okay.
On the RISC-V things, there is also a link that we have on the subreddit, RISC-V from scratch, which is interesting. Basically, you could do everything, right? So you can do toolchain setup and all the way through to like getting. I think this is on the code side of things. But pretty interesting to actually get it up and running. And like I said, I think I'm really bullish on RISC-V in general. I think it's there's going to be some circumstances.
I hadn't noticed.
Right, I know. I know. Circumstantial things that are coming through. I went on a podcast and I talked about it with I was on a 3M podcast, and I brought that up as the thing that I'm most looking forward to is open tool chains and RISC-V. So yeah.
Yeah, no, it's very impressive. Like, even as I mentioned earlier in the show, I got excited when that 3-cent microcontroller, now there's a tool chain for
Yeah,
that.
exactly. Right.
Like, whereas before you had to use this sort of like custom, quirky, single executable downloaded from the manufacturers, some weird, it wasn't even, proper ANSI C, it was like quasi C, and
right.
it was kind
C-ish.
of, like C-ish. And, it was, and you had to buy their programmer, right? You couldn't, and there was just like no information on it. Now it's like, everyone's reverse engineered that, and apparently it works.
Yeah.
So, it's great.
Yeah.
So now it opens that up to greater number of people. It's fantastic.
Yeah. One thing on the 3-cent micro, and then also the tariff stuff too. I went to go order from LCSC today. I was like really excited about it because I had an order with their partner PCB House, and they stopped doing that.
Yep.
Did you know that?
Oh, what they stopped doing the boards?
They stopped. So JLC still does boards, and LCSC still does parts, but it used to be you could buy parts and then
so you can't bundle them anymore.
You can't bundle them anymore. That sucks. Yeah.
Right.
Anyways,
Got
just
it.
from shipping. That's, yeah. I've been. Oh, that was another thing I was going to talk about. Is the I've been doing it where I was really pissed. There was an article that LCSC got some investment from like Sequoia China and stuff like that. And most people don't give a shit about that, and that's fine. But the reason I was upset is because they started listing like legit parts on there. I went there because I wanted to see like. And I would still like to see this. I tweeted about this a couple weeks ago. I still want to see like what is the most commoditized footprint out there. I don't care about brands. I care about commodity.
Yeah.
I want to be able to drop 6 different parts in the same footprint, and so that I have a little bit of like continuity between if a chip company makes something, and it's like you can do that if you go back to the 7.4 series logic and you're on standard footprint sizes and stuff like that. But you can't do that with like switching regulators and microcontrollers and stuff like that. And so I was more.
You can.
Okay, tell me.
Yeah, there are some switching microcontrollers that are generic Jelly Bean, but they're not the best solution.
Yeah,
they're not the easiest
right.
to use. They're not the most efficient. They're blah blah blah.
Right. And I guess some of that I accept. Like the as you go up in complexity, like even the switching regulators that I'm talking about. Usually it's because they're modern parts. They have modern processes, and then they have these crazy ass late or footprints rather. Fine, whatever. Yeah. But like things like switches, I don't care about switches. Like, come on, I just want like the cheapest switch that I can get that a lot of parts will switch into, and that I can keep driving the cost down. And obviously resistors are fine. LEDs are fine. There's
all of your
standardized
regular passives, your transistors, your
right.
All fairly generic Jelly Bean. But once you get up into your more complicated,
even like diodes, just a standard Schottky diode. Thinking there's a ton of parts out there, but I want to just know what is the most voluminous part count out there. That's all I really care about, and I just want to drop that footprint down so that I can usually go figure it out later too. If I can just put a footprint down, I'm like, oh, SOD 123 is fine. I'll be able to find a part for that. That's great. I just need these standard, kind of like that thing we were talking about at the top of the show with vertically integrated design engineering. It's like, if I just know I'm going to drop a diode and I can definitely find a part for it, great. But if I have to go find one of those, NextFET crazy ass, 16 pin, it's like a monstrosity of copper and polyamide and whatever else is in there. It's like, it's tougher. So
yeah,
so that's why I was going to LCSC, and then now it's all like flooded with real parts. That's the end of that story. Sorry.
Oh, what? So LCSC is flooded with real parts? What?
Yeah. So like they started like
because they used to be mostly like
China.
Chinese.
They called
only
it like I think like
part.
Asia brand or something like that. But they were showcasing parts that you usually can only get in China, and that's what the value was to me. Like that's what I care about. But now it's like, oh well, no, you can buy like a little list like a TI part on there or something like that. I don't know if TI's,
which is fine as long as they're not taking the Asia stuff away.
They haven't, but it's just flooding the whole space for me. They want to sell more parts, fine, whatever. I want to go there.
They want to become a mouser and a DigiKey.
Exactly.
They can sniff the opportunity.
Exactly, and that's fine. But I just want to search specifically in the low cost region.
Right. Yeah. Well. Can you isolate that as a filter actually on the website when you I want Asia only brands?
I'm not sure actually.
Is
Maybe.
that,
But it's still gunking up my thing, Dave. I want to.
Anyway, I was going to look at doing that. This is interesting because this 3-cent microcontroller, right? I was going to do a video where I actually built this thing up and got it working and everything. And I was going to like do the community a favor by actually making an online bomb, right, available at DigiKey or Mouser or LCSC or somebody, right, that just had all the parts. Like, you know how on these websites you can post like a public link to a bomb, right? So that if you want to build one of these, you don't have to go in and go, oh, I need this resistor and this transistor and I need this chip, and it takes you hours. Yeah, right. If somebody's already done all that work, you just hit the link for that bomb, order all those parts, bang, they come, right? And I was going to do that with both the parts and the board as well. So I was going to make the board publicly available, because it's open source anyway, right? So I was going to upload it, but then people don't have to do the problem of uploading it even, right? Of like downloading it from the GitHub or whatever and then uploading it to their manufacturer. They can just order it. It's already done. So what is the go-to?
Yeah.
What are the go-to places for making a publicly accessible PCB and bomb list like that? Like, what is, Mouser and TGKey are the obvious ones for the bomb, right? I
mean, for the PCB, I would, normally when I'm sharing something like this, I would just share a GitHub repo. I think that from my perspective, that's what I usually would prefer.
Yeah, but it's but if you like a GitHub repo, right, then you've got multiple steps to do it. If somebody just wants their 3-cent programmer micro, right? That's all they want. They have to go to the GitHub, find the board, download the board, find the correct Gerber files, make sure they're all okay, upload them, check them to make sure they've got all the, the uploads done all right, make sure they've selected all the correct options on the PCB manufacturing side of things, and then cross their fingers and hope they got it all right, and then press the order button, right? Whereas if it's already... you can do this with the microsupply board, and I can't remember where it is. Somebody uploaded it because it's open source. Somebody, not microsupply, the microcurrent board. It's on one of these, public PCB house websites where you can just order one.
Got it. Yeah.
If you want a blank micro current board, apparently you can just push a button on a website and they'll send you one.
Yeah, so like Oshpark has a marketplace like that.
It might be Oshpark. Yeah, it might be.
So Oshpark has that. Right, I think PCBWay has that now. I think.
PCBWay have it. Okay. Oshpark, who was the other one?
PCBWay and Oshpark are the two that I'm pretty sure does that. And then
have a publicly.
I think Seed might do that as well. I'm not sure.
Right, they might. Okay. All right. Yeah. I have to check if LCSC do it, because that's where I get my boards from at the moment. I have to check if they have like make it a public option or something. Don't like PCBWay, don't one of them like make it public by, like, if you use their low-cost service, part of the terms are that you have to make it public or something like that?
I can
vaguely remember something like that. I know. It's like,
I didn't think so.
If you want your boards for $2, you've got to make them public. It's like, otherwise they cost, $10 or $20 or something. I don't know. Something like that. So
that's its own little.
Yep. You have to watch out for
microcosm of craziness. So.
Right.
All right, so we're almost done here. I wanted to ask you about your Apollo 11 stuff real quick. That you did a shit ton of stuff there. So how was it?
I went down there for 4 days. Yeah, I spent 4 days down there talking to the original trackers. I met Andy Thomas, who was the Australian-born astronaut who's been on 3 shuttle missions.
That's super cool.
And that was, it was just an awesome time. Yeah. It's absolutely fantastic.
Awesome.
So, yes, you had a question?
Yeah, just generally about the experience and stuff like this. So those are all those videos are EEV Discover if people haven't seen them. So
most on EEV Discover, some are on EEV Blog 2. There's one on EEV Blog, which is like my own summary kind of video.
Okay, so that might be a good place to start too. And we'll link all those in to anything
lots of fascinating
unexpected
talks
about that. I mean, did you kind of see?
Well, I discovered I had no idea. I had no idea about the ARIA NASA tracking plane.
Oh yeah, that was cool.
Right? People think that to track the Apollo missions that they only had the 3 tracking stations, right? Canberra, which we've been to, the Goldstone one in California, and the Spanish one, right? And people think that was it. No, that was only a third of NASA's entire tracking network. They had not only a fleet of ships, tracking ships, but they also had these tracking aircraft called Aria that actually have this steerable dish in the nose. They converted these 737s. Anyway, Boeing planes,
plane,
right?
Yes.
Back in the 60s. Yeah, anyway, they converted them with this big Snoopy nose on the thing, and these dishes could track, and they were taking these, flying them all around the world so that you can track all of your low Earth, like they couldn't actually talk to the moon, right? They couldn't receive signals from the moon, but you have to track the Apollo aircraft. You have to spacecraft in Earth orbit, right? And the only way that you can't do that with 3 ground-based tracking stations.
Right.
It doesn't work like that, right? Once it goes over in fact, a ground-based tracking station can only track an Apollo aircraft in Earth orbit for like 6 minutes.
Right. I remember one of your videos too. You were talking about this, or maybe it was an older one with Richard talking about the speed of the dish moving. I think it was, and it just can't move fast enough because of the arcs that it's flying through.
It cannot move. It cannot arc. It can't slew fast enough across the sky. So that's why they had to move. The big 70-meter dishes are 0.1 and 0.2 degrees per minute, whereas the tracking dishes, they can do 3 or 5 degrees per minute. They're like 6 or 8 times faster, and they slew. And I met the guy who was in charge of the Aria aircraft. He was there.
That's super cool.
And I got him on camera, did an interview. It's fascinating.
You know what's interesting to me about that is that for some reason, all the other stuff they did, of course there was tons of stuff there, but for some reason that level of like logistics and cost and everything else they did, that makes it feel like it's even more expensive for some reason. Like, of course, they were spending people to the moon. They were spending so much money, but for some reason that's now it's expensive.
No, you have no idea what went. People have no. Even if you're an Apollo buff like I am, you have no idea what actually went on at the lower details of stuff you've never heard about. It just the switching exchanges, right? I was talking to one of the guys there, telling the story about how if it wasn't for me, nobody in the world would have seen those Apollo missions, because I was in charge of this one little line that came out of this telephone exchange and whatnot, and I fixed it. and everyone got to watch it, right?
Great.
Nobody knows this story.
That's great,
right? And if that one line went down, boom, the whole world wouldn't have seen the moonwalk. It's like, people think it's just the dish, and then it's no. There's this whole massive infrastructure of, so many links in the chain. Yeah. It was phenomenal. And you just don't hear about them because they didn't fail, because they worked.
That's right. And
I'm sure if it
and
failed,
there was probably redundancy on redundancy, but at the same point, sometimes...
Oh, no, some of them weren't. Yeah. You'd be surprised at the number of links in that chain that were... if they went down, that was it. There was no redundancy.
Oh, nice.
For certain phases of the mission, for other phases of the mission, but for the actual moonwalk, as Neil's coming down that ladder, there was, it's pretty much a no redundancy.
Yeah.
It was,
Wow.
Yeah. Anyway, crazy.
That is crazy.
Crazy. So, it was like fascinating stories. And these guys, 50 years later, they can tell you which switch they flicked, right, to do this thing. Unbelievable memories. Yeah. Oh, wow. Yeah. It's like it's yesterday for them.
That's great, man.
It's fantastic. Yeah, so... Yep, that was 4 days of just hearing all these stories.
Nerding out pretty hard.
Most of them I didn't capture on camera. Yeah. So,
Well, that's good, man. I'm glad you got to go down there. That
it's awesome.
Was a lot of fun. I saw maybe I saw you share it or someone share it, but that Apollo 11 in real time too. If people haven't seen that,
I shared that. That was fantastic.
Really cool.
And I met the one of the producers of the Apollo 11 movie, and he was he wasn't just the producer, he was one of the guys who actually he's actually an archivist. He's not actually a movie producer. He's an archivist, so he's the one who got all the audio out of the archives and processed all, like 60 different channels, like I'm talking like 6 days worth of 60 different channels of audio that they had to not only get out of the archives, they had to process, polish it, clean up to make it. Then they had to figure out how it all synced and time-stamped and everything else. And sometimes they only had like one little snippet of like 2 seconds in a video where they went, aha, this controller in the back corner there said that, so therefore I can sync up. God. I can use that as a reference point to sync up all this other data over here. Yeah. And it's like, oh my God, they spent years syncing up all this audio.
That's great.
Which, if you haven't seen the movie, watch Apollo 11. Yeah. Oh, and you got to watch it on the big screen.
That's the one, yeah. I was just like thinking about it. I was like, I've seen Apollo 13. I was like, nope, that's not the movie, Dave. That's not the movie, Chris.
No. Apollo 11. You want to know what the best thing about the Apollo 11 movie is? We'll finish with this. The best thing is that there's no commentary.
Oh, really?
There's no commentary. There's no, none of the astronauts talking about their experiences and all that sort of crap, right? You can get that anywhere else. This is just all an hour and a half or 2 hours of all archive footage in order. So they start like 8 hours before the launch or something. And then they take you through sequentially, and it's like, because they had like 50 different cameras, they found all this original 65mm footage and all the original commentary. So there's no audio and no video in this entire movie that wasn't actually recorded by the people on the day.
That's awesome. Yeah.
Yeah, and it feels like you are there, and it's just, it is absolutely remarkable.
I might not take you up on the big screen thing, but they're on rental right now, so I might just go rent it.
No.
I don't know if I can find it on a big screen. I'll see if I can.
Dude, IMAX somewhere. You got to see it on IMAX.
All right, I'll try.
Trust me. It'll change your life. You'll thank me.
All right.
Yep.
Cool.
Yep.
All right, man. Well, we'll talk to you soon.
All right. Catch you next time.
To the moon.